Okay, so for problem 13, they actually give you what you need to use, which is right over here. If you look at the 3 pi over 4 and the pi over 6, that sum equals 11 pi over 12, as I wrote it down here, if you change it to the least common denominator. So what you want to do is just use one of those sum functions. So if I was using cosine, the cosine of u plus v equals cosine u cosine v minus sine u sine v. So in this case it would become cosine of 3 pi over 4 cosine of pi over 6 minus sine of 3 pi over 4 sine of pi over 6. Okay, now 3 pi over 4 is in quadrant 2, and pi over 6 is in quadrant 1. So you know that the sine and the cosine are both positive in the first quadrant, and the sine and the cosine, the sine is positive, the cosine is negative in the second quadrant. So pi over 4, you know the 3 pi over 4 is the same as pi over 4. So this is the square root of 2 over 2. The cosine of pi over 6 is square root of 3 over 2 minus, and then the sine of 3 pi over 4, the cosine of 3 pi over 4 was negative. And then the sine of 3 pi over 4 is positive, so that's square root of 2 over 2. And sine of pi over 6 is 1/2, so I write it like this. And I end up having the square root negative the square root of 6 over 4 minus the square root of 2 over 4. So your answer is negative square root of 6 minus square root of 2 over 4. And that's for the cosine. And then you have to do something very similar to the sine and very similar to the tangent. All you're doing is using this sum right there and then substituting into the identities. The sum of the sine, the sum of the cosine, and the sum of the tangent. You're not going to do differences, and you're not going to do anything else. So you're only doing the sum because they gave you the sum of those angles to get you to 11 pi over 12.